Hi friends, welcome back to my physics channel once again. We are in the 5th chapter and the new syllabus intermediate, that is IPE, intermediate public examination, that is magnetism and matter, and at the end of the chapter. See on the board you can see we are coming to 8 marks question in the 8th video. We are entered into 8th video. Okay na? So these will decide the 85 marks for the new academic year. ఈ లాంగ్ ఆన్సర్స్ కూడా రెండే క్వశ్చన్స్ ఉన్నాయండి మీకు. And for this I am making a separate video, that is 8th video. First question చూడండి, prove that bar magnet, long questions, prove that bar magnet and solenoid similar fields. So he is asking you to prove that bar magnet and solenoid have similar fields. Okay na? Shall we prove for 8 marks? Right, and start chadam. See, we know, for example, first of all I will take bar magnet. I will draw with a red pen. 8 marks kabatti neat ga undalandi. So for example, if I take a bar magnet, you can say north and south. This is the length of the magnet and this is the axis. Now if you observe carefully, the field lines for bar magnet, if you observe, it starts from north, ends with south, because we know no monopoles exist in nature for magnet. Neat lines you can see, closed curves. Okay na? You can see how nicely I am drawing. So you can see closed curves. Okay na? From north it will be going away. Okay na? And for south it is coming towards. So these are the magnetic field lines, and if you draw tangent at any point, you will get the magnetic field area. Ekkada draw chesna. If you draw tangent at any point, you will get magnetic field direction. Anywhere if you draw that, you will get the magnetic field anywhere. If you draw anywhere, ekkada meer daniki tangent draw chesna, akkada you will be getting the magnetic field direction. Okay. So if you observe carefully here for bar magnet, in the same way I will draw for solenoid also. I will draw for solenoid. Solenoid also I told you in the concepts also. So I am putting into means coming outside current, that is dot. Into means going inside, current direction. Coming out, going inside, out inside. So this is the direction of current. బయటకు వచ్చి లోపలికి వెళ్తుంది. You can see the direction of current. Out inside, out inside. So if you know, this is the length of the solenoid, and it is a long solenoid and it is a radius. And for our syllabus you are having, the length is very much larger. So this is the field direction in the middle, magnetic field. Okay na? So current you can see it's coming this direction. Okay na? So it is coming like this, from outside and going inside. So for example, in this case, if the current is in anti-clockwise, then what happens? It becomes north pole. If it is clockwise, it becomes south pole. So therefore what happens? It behaves like a magnet. A solenoid also behaves like a magnet. So depending upon the observation from one side, it is from north pole or south. Ante మనం చూసే విధానం బట్టి it is north pole or south pole. If the current is clockwise, it is south pole. It is anti-clockwise, it is north pole. So what happens? Magnetic lines goes from north to south. So therefore, it is very clear from these diagrams. What you want to do? Prove that the bar magnet will produce same similar. So this is also acting as magnet. North pole and south pole. So lines north and south వెళ్తాయి. అదవుతుందా? Same like this thing. ఇక్కడ ఎలాగైతే బార్ మ్యాగ్నెట్ ఉందో, this is also bar magnet. North pole and south pole. So lines will come in this fashion to south. Clear? So ఎలాగైతే మనకి బార్ మ్యాగ్నెట్లో మనకి నార్త్ నుంచి, బికాజ్ వి ఆల్ నో In magnetism, monopoles never exist in nature. Even if you cut the magnet into smallest piece into the universe, still that small piece, you going to cut this. Still this small piece acts as a magnet, north and south pole. And we have magnetic field here for this one, B center, given by mu naught Ni. This is the magnetic field at the center for solenoid, permeability of free space, and what is number of turns N, total turns by per unit length, capital N by L, and what is I, strength of current in amperes, strength of current in amperes, and mu naught, permeability of free space 4 pi to 10 minus 7 Henry per meter, and BC is the magnetic field at the inside. Okay na? So, suppose if you take this one north to south as the magnetic lines, north to south, okay, north to south, north to south. If you take this one as the north pole, it is south pole, north to south. These are the field lines. So same like elagaithe mana bar magnet lo lines north and south, always they starts from north and ends with south. And you can see the current direction outside, inside, outside, inside, outside, inside. And you can apply the right hand thumb rule here for the lines. Chudandi, current lossundi, lopaliki velli lostundi paiki. See, going inside magnetic field, coming outside. Going inside, you can apply how the magnetic field direction. Chudandi, this current vachindi, you can apply here. See the direction. Okay, going inside, coming. So the magnetic field will be in this fashion. So you can find out as and when the direction of magnetic field for in any direction. By using your right hand thumb rule, you can find out the direction of the magnetic field. Okay, clear? So this is about the bar magnet and solenoid. Both are same, the field lines, and these are closed not open curves. These are closed curves. And no two lines will be meeting each other. If they meet each other, the direction will be in two directions, which is highly impossible. Clear? So that is the first 8 marks question regarding bar magnet and solenoid produce similar field. Last question, explain the properties of dia, para and ferro. Already repeated question and 4 marks for Japan, but I will still tell for you. Second question, ferro, dia and para. So he is asking you to explain 8 marks covered, 8 marks takkat explain cheyali. So let us start with first of all diamagnetic substances. Okay na? Right. Now what are diamagnetic substances? Heading pettukondi. 8 marks covered, 8 marks takkat ivalli. First we will tell about diamagnetic substance. So what are the example for dia? Copper, antimony, bismuth, hydrogen gas, etc. So these are strongly repelled. Copper, antimony, bismuth, hydrogen gas and we repelled, strongly repelled by the magnets. These are strongly repelled by the magnets. Copper, antimony, bismuth. Okay na? So that is the main this thing of the diamagnetic. Tarvata inkenti deen properties chusukunnattugaithe the movement will be from stronger field to weaker field when they are placed in non-uniform. In dia, the movement will be from stronger part to weaker part. Stronger part to the weaker part. So when it is placed in a uniform, non-uniform field, when these diamagnetic substances are placed in non-uniform field, when placed in a non-uniform field, non-uniform field, of course they are strongly repelled by the magnets. The movement will be from stronger part to the weaker part. That is the main thing of the diamagnetic substances. Strong నుంచి weak వెళ్తాయండి. అది second point you can note down for dia. Now let us go to the zeta part. Zeta which is equal to I by H ratio, intensity of magnetization to the magnetizing field, and this value is small and small. Please write down. It is small and negative, please. For diamagnetic substance, the ratio of intensity of magnetization to that of magnetizing field is small and negative. Diamagnetism, okay na? That is called as magnetic susceptibility. It is also called as magnetic susceptibility. Susceptibility. Okay na? And the last point you can take regarding temperature. So the magnetic properties in dia independent of temperature. So here in dia the magnetic properties are independent of temperature. That means if you increase or decrease, there is no effect. So this is about the diamagnetic substances. Copper, antimony, bismuth, hydrogen gas, etc. Strongly repelled by the magnets. They move in a non-uniform field. If you put it, they move from stronger part to the weaker part. And the zeta value, magnetic susceptibility, is small and negative. The I by H ratio, intensity of magnetization to that of magnetizing field. And the magnetic properties does not depend upon the temperature increase or decrease. So this is about the diamagnetic substances. Now let us go to the paramagnetic substances. Dia is over. Paramagnetic substances. See, if you observe these materials, these are opposite to that of dia. First, let us say the statement. These are feebly attracted. These are feebly attracted by the magnets. And you can take the examples as aluminium, manganese, oxygen gas, etc. And if you want, you can take platinum and also magnesium. Okay? But these are the best examples: aluminium, manganese, oxygen gas, etc. These are feebly attracted by the magnets. Okay? That is the main thing. తర్వాత వచ్చేసి డయాక్ ఆపోజిట్ చూడండి. ఇది ఏమవుతుంది చూడండి ఇక్కడ. ది మూవ్మెంట్ విల్ బి ఫ్రమ్ స్ట్రాంగర్ పార్ట్ టు వీకర్. కాబట్టి ఇవేంటి రివర్స్. దేర్ మూవ్మెంట్ ఈస్ ఫ్రమ్ వీకర్ టు స్ట్రాంగర్ పార్ట్. పెరా. ఓకేనా? వీకర్ పార్ట్ ఆఫ్ ద మ్యాగ్నెటిక్ ఫీల్డ్ టు స్ట్రాంగర్. దే టెండ్. సో పెరా దే టెండ్ టు మూవ్. రాసుకోండి. దే టెండ్ టు మూవ్ ఇన్ పెరా మ్యాగ్నెటిక్ సబ్స్టెన్సెస్. ఎలా మూవ్ అవుతాయి? ఇక్కడ ఏమైంది? దే ఆర్ మూవింగ్ ఫ్రమ్ స్ట్రాంగ్ టు వీకర్ కదా. దే టెండ్ టు మూవ్ ఫ్రమ్ వీకర్ ఫీల్డ్స్ టు స్ట్రాంగర్. Opposite of that term. They tend to move from weaker fields to stronger fields. Opposite of dia. Dia they move from stronger to weaker fields in a non-uniform magnetic field. Third point, please. Zeta value. Zeta value is small and positive here, and adotna. Right. So here I by H zeta. That is magnetic susceptibility is. Of course, it is small, but it is positive. Okay. So paramagnetic substances, they are feebly attracted by the magnets, and these are slightly opposite to that of dia. Akadema strong to weaker, they move in non-uniform magnetic field. These tend to move from weaker field to stronger fields, and the zeta value of I by H for them is small and negative, and here it is small and positive. Magnetic susceptibility, and these materials move from weaker fields to stronger field. Last point you can note down for the para, that is Curie's law or Curie's temperature. So here the zeta is inversely proportional to absolute temperature, the I by H. Okay, this is also called as Curie's law. Scientist Curie's law. So the magnetic susceptibility along then inversely proportional. Magnetic susceptibility is inversely 8 marks కాబట్టి 8 marks అక్కడ రాయాలండి. Inversely proportional to the Kelvin temperature or absolute. Kelvin temperature or absolute temperature. So it depends upon temperature. Para. If you raise the temperature, this decreases value. Okay, if decrease the temperature, it raises inversely proportional to para. Note chestunnaru kada. Let us go to the last one, ferro. You can up chestunande right hand. Last part and last one for 8 marks question. This is the 8th video and I am doing for you. Magnetism matter. ఓకేనా, నోట్ చేసుకోండి. లాస్ట్ వన్ రైట్ అండి. సో లాస్ట్ వన్ ఫెర్రో. ferromagnetic substances or materials. So ఇవేంటి సాధారణంగా కోబాల్ట్ strongly attracted. First of all, let us write these are strongly attracted by the magnets. These are strongly attracted by the magnets. Example enti? Iron, cobalt, nickel, steel, etc. These are the best examples for ferro. Strongly attracted by the magnets. Okay na? Tarvata, if you observe the domains in ferromagnetic materials, these are grouped into small regions. If you observe the domains in this one, they are grouped into small regions. Okay, in ferromagnetic substance they are grouped into small regions. Okay, called domains. ఇక్కడ ఏం జరుగుతుంది? And here where all the magnetic moments are aligned in same direction. అదవుతుందా? So ఇక్కడ ఏం జరుగుతుంది? They are grouped into small regions and all the magnetic moments are aligned in one direction. రాస్తున్నారా? All the magnetic moments are aligned in one direction. So very important properties andi. Okay na? Are aligned in one direction, same direction. Clear? So అర్థమవుతుంది కదా, ferromagnetic substance అంటే ఏంటి? These are strongly attracted by the magnets. Iron, cobalt, nickel, steel, etc. Regarding their domains, they are grouped into small regions called as domains, and all the magnetic moments are aligned in one direction. తర్వాత in unmagnetized state ఏంటి అవుతుంది చూద్దాం ఒకసారి. ఓకే, in unmagnetized state we'll study about the ferro. See, in unmagnetized state, okay, and when an external field is given, okay, the domains pointing in the field's direction ఓకేనా, కొంచెం థియరీ పార్ట్ ఇది. బికాస్ magnetism matter itself is a little boring chapter. So some theory part you have to study. అన్ని కూడా మన mathematical part ఉండవు. So some theory will be there. You have to go, otherwise you won't get marks, full marks. ఓకేనా. So see that one. In unmagnetized state, when external field is applied, in unmagnetized state ఏమవుతుంది, when external field is applied, okay. So what happens here, domains pointing okay, in the field's direction, domains pointing in the field's direction. Okay, in unmagnetized state, the domains will pointing in the field's direction, please. Okay, and what is happening here, they grow larger and the other domains rotate along with the field అనమాట. అర్థమవుతుంది మీకు. సో దీనివల్ల ఏమవుతుంది మనకి, ద రిజల్ట్ విల్ బి ఓవరాల్ మ్యాగ్నెటిక్ ఎఫెక్ట్ ఎక్కువ ఉంటుంది అనమాట. వెరీ స్ట్రాంగ్ ఓవరాల్ ఎఫెక్ట్ ఉంటుంది. సో దట్ ఈస్ ద మెయిన్ థింగ్ అండ్ హియర్ థియరీ పార్ట్. సో అది మనకి క్వశ్చన్ అడిగాడు వాడు డిఫరెంట్ పార్ట్స్. తర్వాత మీకు ఇంతకుముందు ఒక టేబుల్ కూడా ఇచ్చానండి, మీకు గుర్తుందో లేదో. ఎస్, యూ కెన్ ఆల్సో అటాచ్ వన్ మోర్ పాయింట్ ఫర్ దిస్ వన్. In ferro, if you observe ferromagnetic, the zeta value is very much larger. See, in ferromagnetic substance, the I by H, that is magnetic susceptibility, is very much larger than 1. Please note down. Okay? In ferromagnetic substance, the zeta value, ferro, compared to the dia and other thing, its value is very much greater than 1. And also relative permeability is also very much greater than 1. Relative permeability is also greater than 1, mu by mu naught. If you want that additional information also you can take it. And mu is also greater than mu naught. So these are some important points regarding ferromagnetic substances. These are strongly attracted by the magnets, iron, cobalt, nickel, steel, etc. These domains, when they are grouped into small regions, all the magnetic moments are aligned in one direction. In unmagnetized state, when an external field is applied, domains pointing in the field direction. And regarding the zeta value, magnetic susceptibility I by H, intensive magnetization to the magnetism field ratio is greater than 1, and also relative permeability is also very much greater than 1, and also the absolute permeability is also very much greater than permeability of freeze. This is already I given for you in the table. Okay, na? Regarding ferromagnetic. Zeta very much greater than 1, mu r very much greater than 1, and mu is also very much greater than mu naught compared to the para and diamagnetic substance. Okay, Andy. So that's it, Andy. These are the 8 marks questions regarding the chapter, long answer questions. Okay, na? Right, Andy. Again, I will be meeting with another numericals and almost over. The chapter is over. 8 videos are completed. In the 9th video and 10th. In 9th, I will be telling numericals. I think you are having for the new textbook 1, 2, 3, 4 numericals you are having. That's all. And in 10th video, we have 1, 2, 3, 4, 5, 6, 7. 7 numericals. Separately, make it individual chastam. Okay. Again, I will be coming with the numericals, examination numerical in the 9th video, please. Okay, na? Right.